This video is going to focus on learning the concept of concentration, specifically focusing on a concentration unit called molarity, which is referenced in this learning target. There's another concentration unit called molality that we'll deal with a little bit later. So when we talk about concentration, what we're talking about is how much of the two things that you have are that you're mixing together. Okay, so how much of any given substance there is that you're mixing into the other substance. The thing to be aware of whenever we talk about a concentration unit is we really have three different things that we can potentially measure within a solution. We have the amount of solution, we have the amount of solvent, and we have the amount of solute. Depending on how you're measuring concentration, you might be measuring any one of these three things. So how do we calculate concentration with molarity? The molarity specifically is a number that's telling you how much solute there is in a total amount of solution. So here's your relationship. Molarity is big M. We've seen big M a couple different times. And big M specifically means this is the amount of moles you have per liter of solution. So the unit on molarity is similar to like the unit on density. Density is grams per liter. Molarity is moles per liter. Now, when you look at this, it doesn't seem super complicated in terms of how you're going to do the math or the concept behind it. But one thing to be aware of is we don't have a mole scale. So in terms of making molarity practical, you're frequently going to be converting between grams and moles, which is no problem because you see grams, you see moles, you think molar mass. And the other thing is most graduate cylinders are in milliliter instead of liter, so we're going to have to be using that relationship that there are 1,000 milliliters in 1 liter very frequently. So here's an example problem with molarity. This is asking what is the molarity, giving you a gram amount and a volume amount. Honestly, depending on the type of problem, I do all of my concentration problems differently. If I have a problem like this where you're asking me for molarity, I know molarity is moles per liter. So if I want to get big M out, I have to have a mole amount and I have to have a liter amount. So I read my problem. Okay, I see I have a volume, but it's in milliliter. Okay, I have 400 milliliters, and it has to be in liters to use this relationship. So I'm going to get that to liter using the conversion factor, which means essentially I divide by 1,000, or I move the decimal place over 3. And I have 0.4000 liters. And that's what's going to go here. I don't have mole, but I have grams, and that should be a no-brainer for you that if you see grams, you can get moles with hardly any effort. Okay. You see grams, you see mole, you think molar mass. So for every 1 mole, I've got 74.548. Grams of potassium chloride, multiply that out. In the 85 grams, I have 1.14 moles. That goes here. So the concentration of this substance is then 1.14 moles divided by 0.400 liters to get to concentration. Final concentration of this thing, we're limited by 3 significant figures, 2.85. The unit on that then will be big M. Molarity is always reported in big M. You could also potentially write moles per liter, but most people just write big M. Now instead if I'm given a problem like this, where I'm given concentration and volume and asked for a mass, I know big M still is moles per liter, so I can plug into this to get to one of my unknowns. You can also always use concentration as a conversion factor if you want. So that 0.100 big M is actually 0.100 moles in 1 liter. So that's a conversion factor that actually allow you to convert from moles to liter or liters to moles. So if I use this then, I'm given in the problem 200.0 milliliters, which I can make into liters the same way I did before. I have 0.2. And that's the number I'm starting with. I'm trying to say if I have this many liters, and for every 1 liter I have 0.100 mole, how many moles do I actually have in this problem? So that's my starting number. If I multiply it by this relationship, I would get moles out. Now you're not looking for moles in this problem, you're looking for grams, but you always know you can go gram to mole given a molar mass. So the molar mass of sodium chloride is 58.44, and then you can just multiply this in one step to get you to your final answer of how many grams there are in 0.200 liters of this solution's concentration. So this is a key component on this. Every time you have 0.2 liters of a solution, you won't necessarily have this relationship. This relationship is established within this problem. Same as a mole ratio is established within any chemical reaction. So if you do this one out, then you get 1.17 grams of sodium chloride are actually in this solution. We're going to be dealing with concentration a lot, right, in terms of calculation, but these problems are no harder than density. It's just that you have the extra calculations, the mole to gram or the milliliter to liter problems that make them a little bit more complicated. Now in class tomorrow, you're actually going to come in and make a solution. And what I want to show you guys, and I'll show this tomorrow, is what we make solutions in. And this is called a volumetric flask. And the reason we make them in this is because of what molarity is. Molarity is solute in solution. The problem is to make a solution, you measure out solute and solvent, right? That's what you have. But that's not what your calculation is dependent on. Right? If you want to make a solution where you're going to put in 10 grams of sodium chloride, you need a way to measure out the full volume of your final solution to be able to calculate the concentration correctly. The problem is if you measured out like 100 milliliters of water and then dumped your 10 grams of sodium chloride in it, you wouldn't necessarily end up with 100 milliliters of final solution because the volume of sodium chloride will increase the volume of the water. And we don't usually know the volume of our solute to begin with, right? That's measured in grams. So the reason we use this volumetric flask is because they have a line on them that tells you what the volume is of the flask. So after you mix, if you take your solvent and fill to this line, you'll know that that's the total volume of your solution. So this is a really easy way to mix because it has the big bulb on the bottom, but also to get to a final volume that's prescribed by the container. So I'll show you how these work tomorrow, but again, the reason why we use these is because if you measure out your grams of solute and then your volume of solvent and mix them, you wouldn't necessarily know the volume of your final solution, and concentration in molarity is solely dependent on that being your denominator. So you have to have a way to guarantee that you know what that volume of solution is. Go ahead and do the form and have a nice night.